Welcome to GEOG485 585L, Internet Mapping, Module 4.2, Interoperability Standards, WFS and WCS. In this lecture, we will be covering the basic characteristics of both the Open Geospatial Consortium Web Feature Service, or WFS, and Web Coverage Service, WCS. And for both service standards, we will be discussing their capabilities and purpose, providing an overview of the commands related to each standard, and providing sample requests related to each standard. Starting with the OGC Web Feature Service, we can first consider how the standard is defined by the Open Geospatial Consortium itself, with references to the standards documents provided as links in this slide. So from the version 2.0 scope section of the specification, you can see that the standard is focused on transactions for access to geographic features independent of the underlying data store, supporting discovery, query, and locking operations in terms of being able to enable transactional processing of features stored within a web feature service, and operations that allow you to manage stored query expressions as well. So overall, the discovery operations allow you to basically ask a service to define its capabilities and to return to you information about the capabilities of the service and more detailed information about the specific feature types that are available from the service. The query capabilities of web feature services allow you to request subsets of features from the service that meet particular criteria that you define using the standard query language that is supported by the web feature service. Locking capabilities allow you to essentially identify particular features for that should be locked while they are modified outside of the service. So this provides the core capability for being able to check features out and prevent them from being modified while they are checked out, so that then you can update those features, transmit those updated features back to the service, and then unlock them without having to worry about other clients also modifying those features while they're locked. This relates to the transaction capability of the web feature service, where features can be created, changed, and replaced and deleted from the data store itself. And the locking capability goes hand in hand with this transaction capability when you're talking about existing features that are being modified or replaced. Finally, the stored query capabilities of the web feature service allow for the creation and internal storage of named queries that are stored on the server and that are then published as named queries that can be executed in subsequent interactions with the server. So once a named query is defined as a stored query, other clients can make use of that same query as opposed to having to develop those queries from scratch. The stored query capability is a new capability in the version 2.00 web feature service definition. The more detailed information about WFS that I will be discussing in this lecture relates primarily to the capabilities of the version 2.0 specification, and we will be focusing on some of the more basic interactions with the web feature service, and when there are differences between those basic functions that are based on the WFS 2.0 specification when compared to earlier versions of WFS, I will highlight those differences. So there are a number of requests and operations that are supported by web feature services. And they are submitted as a part of the request parameter key in a submission to the service. So just as we were talking about for web map services last week, the request equals get capabilities, get map, or get feature info operators that we discussed last week have corresponding operators for a web feature service that include the following. First, as with web map services, there is a get capabilities request that can be submitted, where this is, just as with web map services, the key request that will return to you the XML metadata that documents the capabilities of the service that you're interacting with. Unlike web map services, the web feature service standard also includes a second metadata request called describe feature type that provides more detailed information about a particular feature type, where feature types can be thought of as essentially layers if you've worked in other geographic information systems. Another request that can be submitted to a web feature service is a get property value request, which allows you to request the values for a specified property as provided by the list of available properties if you perform a describe feature type request against the service, where you can obtain the property values for a specific feature type using the get property value request. Another key feature of the web feature service standard is the get feature request, which allows you to actually obtain the features themselves, those points, lines, and polygons, and their associated attributes from the service. That get feature request may also include both spatial and non-spatial query attributes as a part of that request. And as a result, the composition of a get feature request can get fairly complex as you define query constraints as a part of the submitted request. There's the lock feature request, which we've already discussed briefly, which allows you to specify a particular feature that should be locked for a given period of time while that feature is potentially being updated or modified outside of the service, where that feature will not be otherwise modifiable within the service. That lock feature request again goes hand in hand with this transaction request that allows you to create, update, and delete features within a web feature service. In a few minutes, we'll talk about different types of web feature services and how these commands relate to those different types of services, as both the feature locking and transaction capabilities are optional characteristics of a web feature service. Finally, we have a set of request types that relate to the new stored query capability within the Web Feature 2.0 standard. The first is the create stored query request, which, as you might guess, is a request that submits a query to the server as a named query that is requested to be stored on the server for future use. The dropped stored query is the corollary to that, where it is a request to remove a specifically named stored query that has previously been saved on the server. So you can create stored queries using the create stored query request. You can delete stored queries with the drop stored query request. If you're interacting with a version 2.0 or above web feature service, you can also submit a list stored queries request, which will provide you a listing of the named queries on the system so that you can know which ones might match your needs in terms of interactions with the system. Finally, the describe stored queries request provides more detailed information about specific queries within the system than you get from the list of stored queries. As I mentioned, the implementation or requirements for support for these different request types varies depending upon the conformance class that the particular implementation of the web feature service is targeting. These requests have also changed from one version of WFS to the next. And this table provides a summary of some of those changes and also the correspondence between the request types and the different types of conformance classes with the version 2.0 of the web feature service standard exist. So for example, you can see that in the previous and current version of web feature services, the get capabilities request is required, as it is also required for all conformance classes, whether we are talking about the simple conformance class, the basic conformance class, the transactional conformance class, or the locking conformance class. Get capabilities is required for all of those. As is the case also for the describe feature type request, the list stored queries request, the describe stored queries request, the get feature request, and the stored query request. You can see that that is required for all WFS version 2.0 conformance classes. As we move from the simple to basic conformance class, we add support for the get property value request. So only servers that implement the basic conformance class level, which is higher than the simple class, support the get property value request type. Similarly, only with the implementation of a transactional conformance class do we then add the transaction request as a supported request for that service. Finally, only with a locking conformance class implementation do you also add the requests that allow you to retrieve a feature either with the get feature with lock or the lock feature request for as a part of the interactions with the server. You will also see that if we look at the two version columns in the table, that a number of requests were added in the transition from version 1.1.0 to 2.0.0. In particular, those request types relate to stored queries. And you'll see that there are no stored query related requests as a part of the earlier 1.1.0 standard. Also, in the transition from version 1.1.0 to 2.0, the get GML object request was removed from the standard, as that capability has essentially been subsumed within the more general get feature request, which has remained available in both versions. While we will be discussing are examples and requirements based on the 2.0.0 version of the standard. We will be illustrating interactions with servers using the earlier standard, as the implementation of the 2.0.0 is still relatively light, and the number of services that are published using that standard are not yet very numerous. But as that is the current standard, that will be the standard that we focus on in terms of describing the parameters that you would use to interact with such a service. When interacting with a web feature service, you can submit requests using one of three standard protocols. You can use the HTTP GET request, where you essentially compose a web address, just as we were discussing last week for web map services, that you can actually type into the address bar of a web browser, where all of the information needed for the request is included in that web address as a set of key value pairs, abbreviated throughout the rest of this presentation as KVPs. An alternative method for submitting requests to the server is using the HTTP POST request model, where all of the request parameters are enclosed in an XML file that is submitted as essentially the content of a post to the server. We haven't really discussed post submissions in any detail, as they're somewhat beyond the scope of our class here, but the HTTP POST request model is actually the more frequently used model as applications develop support for interactions with web feature services. But they're also more difficult to do experimentation with, as you have to write the XML document separately and then submit it using a utility program that allows you to submit that XML document to the remote server. Also, there's support for the Simple Objects Access Protocol, or SOAP, where you essentially use the encapsulation model for the SOAP standard for sending the parameters to the server and receiving the response back from the server. We mentioned SOAP very briefly a couple of weeks ago as we were talking about web services and services-oriented architectures. And in some instances, the SOAP method of exchange is more easily integrated into some enterprise web services systems where they're using SOAP for other transactions within the system. The requirement of the standard is that a server has to implement either one of these three standards, but it does not specify which one any particular implementation should use. And as I mentioned earlier, it's important to keep in mind that as we use the term feature type in our discussions about web feature services, feature types essentially correspond to layers or collections of features that are of the same type. So if we start thinking about the more detailed characteristics of the web feature services request model, the first thing we need to think about are the base parameters that are required for all requests that are submitted to a web feature service. And as you have already seen with the Web Map Services protocol, you must specify a service parameter, where in this case, that service parameter will always be equal to WFS. Just like when we were working with Web Map Services last week, where the service was equal to WMS. In all interactions with a web feature service, the service will be equal to WFS. Also, in all requests that are submitted to a web feature service, except for the Get Capabilities request, you must also provide a required version parameter. Whether it's version equals 1.1.1 or version equals 2.0.0, you must always provide a version number as a part of any request that you submit to a web feature service. If we look at a sample Get Capabilities request to a web feature service, you can see in the first example, which is a Get Capabilities request for the USGS Framework Web Feature Services web page, you can see the request consists of, in this case, the host name. And for this particular service, USGS has an additional parameter after the question mark that is used internally by their service to identify the particular data store that is being used by the service. That is separate from the parameters that we are submitting that relate to WMS. Here, the request equals Get Capabilities, and the service equals WFS. This is the absolute minimum information that you need to provide for a valid Get Capabilities request. You will encounter services like this that have some additional information in the base web address that are above and beyond the parameters that are required for the web feature service. You must keep an eye out for those and make sure that you include them in your requests just as you would include the rest of the host name and the path in the first part of the request. If you leave that off, it's likely that the service will not respond appropriately. So you may have a base URL that includes additional name value pairs, and you just need to make sure to include those in any requests that you submit to the service later. The second example here is a request to a web feature service that is published on the New Mexico ARGIS system, where we have also included the optional version. It is optional for the Get Capabilities request, but not for any other requests. But it is appropriate to include the version if you would like. You can see in the case of this service that the base URL in this case does not include an additional key value pair. But again, you must keep an eye out for services that do, like the USGS service. So what does the output of this Get Capabilities request look like? If I click on the link, the live link here, that submits the Get Capabilities request to the server. And in this case, my browser automatically recognizes it as an XML document and displays it in the browser. You should remember, though, that depending upon the browser that you're using, in some instances, the capabilities request result may appear as what looks like just unformatted text in your browser window. If that is the case, you should do a view source on that returned document to see the underlying XML. Here I'm using the Chrome browser, which does recognize the returned document as an XML file and displays it accordingly. So let's talk about some of the content and structure of this capabilities document that we have requested, in this case from the USGS Framework Web Feature Service. So first, we have this overall container for the capabilities document, which in this case is the element named WFS capabilities. And you can see the large number of additional namespaces that are included as a part of the definition of this XML document. That WFS capabilities element is the root element of this document. We can now look at some of the high-level elements within this capabilities document, starting with the service identification section. This section right here, where you can see we have the title of the service, which is USGS Framework Layer WFS, an abstract for the service, which in this case is just a brief description of the service itself, a block of information that relates to the keywords for the service. In this case, there's one keyword that is defined for it. We have here a definition of the service type and a listing here of the versions that are supported by this particular service. A statement that there are no fees required associated with this service, and likewise no access constraints for interacting with this service. We can now look at the block of information about the service provider. This is the information about whom you might contact if you have questions about the service, or whom you might cite in using the service. So in this case, the name of the service provider is USGS. The provider's website is provided here as an Xlink href element that points to, in this case, the framework WFS website maintained by USGS. We now have a block of content relating to the service contact that includes the name of the individual that should be contacted with any questions, their position, contact information for them, including a number of phone numbers, their mailing address, and an online resource for additional information about that individual, which in this case points back to the USGS website. We then have the operations metadata section, which relates to the different requests that can be submitted to the system. And there's a block of information within this that corresponds to each of the operations supported by the service. Just as with the web map services, where we were seeing, say, for example, the format type supported by a get map request was contained within the request section relating to get map. Here we have a similar structure where we basically have a block for each operation with the name of the specific operation provided as an attribute to the starting operation element for that block. We can see here, this is the information that provides the base web addresses for interacting with the service, and you'll note that as I was discussing earlier, this base address includes that additional data store equals framework key value pair, indicating that you need to include those in all of your requests to get capabilities requests to this system, in addition to the required get capabilities key value pairs that you would also add as a part of the web feature service. We see here, these are the accepted versions for this particular get capabilities request. So if you were to specify a version associated with that request, you could specify one of those two values, 1.1.0 or 1.0.0. You can see here the accepted formats for the requests is basically text XML. So you can only specify a format of text XML, which is also the default for the get capabilities request. This defines an additional set of sections that are available as a part of the get capabilities request. And that is all of the information about the get capabilities request. You can see that the next section we have relates to the describe feature type section, which again has the pair of request base addresses that you can access. These are often the same all the same within the service, but sometimes they're different for different operations. We can see in this request also then a listing of the type names. These are the feature types that are available within this particular web feature service. So this is the first indication of the names of the different feature types that are available by the service. Here we see a larger list of output formats that are available when requesting feature type information. So this is the information about the feature types, not the feature types themselves. But these are the advertised formats which you could use to request the feature type information. And that's the end of the describe feature type block. Then when we get to the get feature block, again, it's just another operation element with the name set to the particular operation that we're interested in this case, get feature. We again have the base web addresses, which are the same as for the previous ones. We have the available output formats, which is a fairly long list of formats that you can potentially request from the system. And again, these are the formats for the actual features that would be returned as a result of the get feature request. And these should not be confused with the formats that you would otherwise get when requesting that a feature type be described or the get capabilities request. You also have some additional information about values that are available for the result type information from the service. And then the end of this particular get feature operation. We then have, basically, we move beyond the operation specifications, and we can then move into the service information, which is here. This is again documenting that this is a web feature service. Very simple. The versions of this service that are supported overall, 1.1.0 and 1.0.0. A long list of supported spatial reference systems, or SRSs, which you can see here by this SRS parameter name, and then this long list of values providing the specific SRSs that are supported by this particular service. Information about whether or not this particular service supports SOAP requests as an additional way to submit requests. And in this case, this service does support the SOAP protocol for interactions. We then get down into the section where high-level information about the different feature types are provided. Here we have information about the available operations, which include query operations. And then we start our list of the specific feature types and the information about those feature types. This is analogous to the layer information that you were seeing in the capabilities document from the web map services that we talked about last week, where this is a single feature type here. This is the name of that feature type, the more human readable title of that feature type, the default spatial reference system, that if no other spatial reference system is provided as a part of the request, this will be the spatial reference system used in the response. The bounding box for the data for this particular feature type, expressed in this case in WGS84 latitude longitude coordinates. You can see that the format of this bounding box is different from the one that we saw associated with layers in the get map or in the web map service request last week in the get capabilities document for web map services, where the WFS standard provides a definition of separate lower corner and upper corner coordinates for the bounding box. And then we reach the end of the information about that particular feature type. As you can see, the information provided here is fairly brief in terms of the information about the feature types. That is because we can use the describe feature request to obtain much more detailed information about each one of these feature types as we need it. So here we have an additional feature type with, again, a name, a title, default SRS, WGS84 bounding box, and then a number of others. So we can see that this particular service advertises a fair number of individual feature types as a part of the single service, where each one has its own name, title, default EPSG code, and bounding box. So this is all of the information that you could start with for being able to then get more detailed information about each of the supported feature types. We now also, since this is an older standard, it also supports the get GML feature request. And as a result, there's additional information in this particular get capabilities document that talks about each of the feature types and the output GML formats that are supported for the get GML feature request. And so you can see there's a GML object type for each one of the feature types identified in this service. You will not see this as a part of the get capabilities request from a version 2.0.0 web feature service, but this is something that you may see in older web feature services like this one. So again, we have the name of the feature type, and then a listing of the output GML formats that are supported specifically for the get GML feature request to this service. Again, this is separate from the get feature request that we talked about earlier, and this is not the same list of formats that are supported for the get feature request. These are formats that are supported by the get GML feature request. And you can see we have a number of these, each one corresponding with one of the feature types up above. We then have information about the filter capabilities of this particular service, where the specific capabilities of the service are defined in terms of the types of operators that can be used in developing a query for specific features. So in this case, you see here that there is a block that corresponds to geometry operands, where essentially it supports 4 types of operands: points, line strings, polygons, and envelopes. So these are the types of features that you can refer to when developing a query. There's then a block of spatial operators that you can use as a part of the queries for determining whether or not particular features should be returned as a result of a query. So whether they're within a particular bounding box or B box, whether they are equal to each other, whether they intersect, touch, or cross each other. These are all the different spatial operators that are available for this particular service. You then have a number of operators for doing comparisons and other types of operations for comparing things. So in this case, we have a list of essentially no logical operators. You can see this is a self-closed XML element. We have here a set of comparison operators that you might use in developing a query if one value is less than another, greater than another, etc. Arithmetic operators that include simple arithmetic and then some additional functions in terms of minimum and maximum values. And that takes us to the end of our set of essentially our comparisons that are within this scalar capabilities element. We have a very brief section here that talks about ID capabilities in terms of what types of identifiers are used. And then we reach the end of this capabilities document. So this is a general overview of the sections that you will see in a capabilities document and what that content looks like. So once you have obtained an initial list of feature types from a service, you can then get more detailed information about specific feature types by submitting a describe feature type request to that service. To do that, you need to provide some additional parameters as a part of the request as optional parameters. If you do not specify these additional parameters, then the default, for example, for type name will be all of the feature types, which may be more information than you need. The output format parameter is also optional, and so if you would like to just receive the default version 3.2 GML representation of the information about the feature type, you can avoid submitting the output format. If you would like to specifically request one of the other supported formats, you need to supply this output format request parameter. So what does this describe feature type request look like? We again have 2 examples here. The first one being a describe feature type request, again to the USGS framework layer web feature service, where we have the base URL that we saw as a part of the information for the describe feature type request. We then have the required service parameter equals WFS. We have the required version parameter now, as this is a describe feature type request, so the version is required as a part of this request. And the required describe the request equals describe feature type request type as well. With these three elements, these key value pairs being required for a described feature type request. In this case, we have also provided the two optional key value pairs. The first one specifying that we would like the response to the request to be in GML version 3 as a part of that output format equals GML3 parameter. And then here we have specified the specific feature types that we would like more detailed information about with this type name equals, and then these 4 type name names separated by commas. You might remember that there was a larger number of feature types included in the service when we looked at the capabilities request. But this specific request limits my interest only to those 4 listed feature types. So if we look at this request and its product, we can see here that we first start with our document root, which in this case is actually an XML schema document, because the results that are being provided are in the form of an XML schema that defines the structure and content of each of the feature types that is a part of the service that we requested. So here we can see this is an XML schema document that we're looking at. If we scroll down, we can see that we then have a section where we're defining an element and then giving it a name and other characteristics as part of the schema definition. We haven't talked about how to write an XML schema document, and so the detailed structure and model for this particular document is beyond the scope of what we're looking at for this class. The one thing that I would suggest is that you can look through this and gain some understanding of the data types that are a part of a particular feature type that you're working with. So in this case, we actually have the definition of the different named elements within the feature type that then have their types defined as different types of variables. This is information that if you wanted to go into great detail in understanding what the contents of a particular feature type were, you could read this schema document and gain that information. And as we just scroll through here, you can see that there's a block in this for each of those 4 feature types that I requested, and only those 4. So we've now looked at 2 types of metadata about the individual features. But of course, the primary reason for using WFS is to actually request the data themselves so that you can get the actual geometries and their associated points, lines, and polygons. That capability is provided by the get feature request, which actually can consist of many options in developing a request. Fortunately, in the version 2.0.0 WFS standard, the default request has actually been significantly simplified so that you can do a basic request more easily, but there's still a very powerful capability for being able to really nail down the details of a request if you want to modify them. So what we see here is essentially the pointers to the set of keywords that you would use in your keyword value pairs for an HTTP GET request to a web feature service, where you can see that these key value pairs fall into essentially 5 categories. The first being the common keywords that we've already looked at in terms of the request type and version, service, etc. But then 4 additional groups of key value pairs that you may also want to use, falling into these 4 categories, and we'll talk about those right now. So first, there are a set of optional presentation parameters that you can specify, where these define essentially how the resulting features will be presented to you in terms of output format, some subset of features in terms of the number of features that would be returned using the count parameter, whether you want to actually retrieve a section of output that starts from somewhere other than the first feature to be returned using the start index, and then the result type where you can actually get separate results as a part of the output. The second set of key value pairs that you can optionally provide as a part of a GET feature request relate to what are called the resolve parameters, where the resolve parameters allow you to specify whether or not content that is included by reference in the source data should be resolved or delivered essentially as pointers to those remote resources. This is a fairly complex concept where all of the data that can potentially be delivered may actually come from multiple sources, and those sources can be referenced within the data that would be returned. These resolve parameters allow you to basically instruct the server to resolve those values before sending the data or not, and if so, how deep the server should go in resolving those. This is, again, a fairly complex concept that is beyond the scope of what we're talking about here. But this provides for a very powerful method for essentially building composite data sets on the fly that may consist of source data derived from multiple locations. The third set of key value pairs that can be provided include first the mandatory type names parameter, which is essentially where you specify the specific feature types that you would like the features returned for, and then a set of optional parameters that relate to defining the additional filter conditions that should be applied to the feature types before they are returned, allowing you to specify, for example, the spatial reference system that should be used for those returned features, whether or not an additional filter should be defined, what bounding box should be applied, all of those additional ad hoc query conditions that can be applied and defined essentially on the fly in a submission to the server. And finally, we have essentially the set of keywords that relate to using stored query parameters that have been previously added to the web feature service, where you can, instead of presenting an ad hoc query, as we saw in the previous slide, you can refer to by an identifier an existing stored query on the system, where you are required, if you're going to be using a stored query, to provide this stored query ID parameter and its corresponding value, and optionally a set of stored query parameter values that are potentially inputs into that stored query. So this is a way where, instead of having to define an ad hoc query, as we saw on the previous slide, you can just make use of a stored query that is already available within the system. After the complexity of all of the options that I just described for interactions with a web feature service, it is possible to actually compose a relatively simple request to a web feature service in terms of a get feature request for data from that service. You see two examples of such a request to the USGS framework web feature service here, where we basically have defined in the first request the base request here, and then the required version, service, and request parameters, which in this case the request parameter is get feature, as we are doing a get feature request. And we are simply specifying the type name for the specific feature type that we are interested in. So with this basic request, I will then have the default set of features returned for this particular feature type. And I can click on the link here that corresponds to this request, and the data are now being downloaded from the USGS server. Since I didn't specify the output format, I am receiving the data in the default GML format for this particular service. The data are still downloading in this case, and in a moment I will then have the full file that, again, depending upon my browser, will either be displayed as just a block of unformatted text, or if my browser recognizes it as XML, will appear as this formatted XML that we have here. So in this case, this is the GML output of that particular get feature request. And so all of the data, the points consisting of the nodes defining the boundaries and the associated attributes for each feature in this data set have been now delivered to me, where I could use it potentially in a GIS application or even in a web mapping application. Similarly, I have only slightly modified that request that we just looked at in the second example here by specifying a separate output format. In this case, output format equals GML3L1, which is a variation on the GML3 standard. And if I click on that link again, this request is submitted to the USGS server, and the data stream into the system. And then if I were to wait for the delivery of the complete data set, I would then see the XML representation of those data, just as we have here. And we could look at a similar request to the get feature support for the New Mexico ARGIS web feature service for the state boundary for New Mexico. So let's move on now to the OGC Web Coverage Service, which, like Web Feature Service, is a service standard for the delivery of data, but in this case, Web Coverage Services, as you can see, as is discussed in the introduction text from the OGC WCS 2.0 introduction, is designed for the retrieval of geospatial data as coverages. As they say, a digital representation of information representing space-time varying phenomena. So, the version 2.0 of WCS actually consists of the core standard, which is linked from the first link provided on this slide, but then also a set of extensions that build upon that core that define the specific connection models to a web coverage service. So it is through those extensions that the separate capabilities for, say, HTTP GET versus HTTP POST versus SOAP are defined. So when you think about the comparison of web coverage services to web feature services, both web feature or web coverage services deliver data, but web feature services are primarily focused on features as defined by points, lines, and polygons and their associated attributes, and it's sometimes complex combinations of points, lines, and polygons, while web coverage services are often optimized for the delivery of gridded or raster data, but even more so multidimensional data where you have both a temporal and a spatial component, as WCS allows for retrieving data from a WCS using both spatial and temporal parameters for filtering what is going to be returned. So in contrast to web feature services, WCS actually has a very much simplified request-response model in terms of the operations that it supports, which are only three. The first, as with web map and web feature services, is the get capabilities request, which, like those other services, returns an XML document that provides the information about the service as a whole and also high-level metadata about the coverages that are available through that service. Similar to web feature services, more detailed information about individual coverages can be retrieved using the describe coverage request, where you can specify one or more coverages that you would like additional information about beyond the brief information provided as a part of the Get Capabilities XML document. And finally, there is the Get Coverage request, which is a request for the actual data values themselves, where that request includes information about the spatiotemporal parameters that define the area of interest and potentially time of interest for the coverage to be returned. It is also through the Get Coverage request that you can specify returned file formats and other characteristics of the returned data. As with our other discussions of the web feature and web map services, there are a variety of methods for submitting requests to a web coverage service. And as I already mentioned, those methods have actually, for Web Coverage Service 2.0, been defined as extensions to the WCS core standard. So we actually have 3 separate extension documents that define the methods for HTTP GET, HTTP POST, and the XML SOAP interaction models with web coverage services. We will continue focusing on the HTTP GET key value pairs approach to interacting with a web coverage service, but as with the web feature service, the HTTP POST and SOAP request models are frequently used for sort of enterprise grade or application interaction with WCS services. But for simplicity's sake, we will be focusing here on the HTTP GET request model. So as with our other services, there are base key value pairs that are required for any interactions with a web coverage service. And those are the same base key value pairs that we've discussed for the other service types. First being the service parameter, which in this case, and for all interactions with web coverage services, would be set equal to WCS. And the request key that will be set to the name of the specific operator being used, whether it's get capabilities, describe coverage, or get coverage. Also, for all of the requests except for the get capabilities request, there is a mandatory version parameter that should be set to the version number of the WCS standard that is being used for the particular exchange. So if we look at an example of a get capabilities request to a WCS service, you can see here that as with our other services, it is a very simple request that includes, in this case, the base URL, the base address, and then the 2 required parameters of service equals WCS and request equals get capabilities. With this simple get capabilities request, you will then receive an XML document that defines the service metadata for that particular service, which hopefully by now is starting to look fairly familiar. So starting with the service identification section, we can see that there is a title for the service overall, an abstract for the service, a set of keywords for the service, a specific statement about the service type, the version of the service that is supported here, and then information about fees and any access constraints related to the service. And that's our entire service identification block. We then have our service provider block that, like our other services, provides information about the provider, their website, contact information for that particular service, including information about their role relative to the service, and then, as with the web feature services, metadata about each of the operations, starting with, in this case, capabilities, providing the base URL for the HTTP GET request. Again, information about the service type, the version of the service, again relating specifically to the GET capabilities request. And that's all of the information about the GET capabilities request. For described coverage, again, there's this block that defines the base URL, which, as I mentioned previously, is often the same for the different operations, but it does occasionally change. So it doesn't hurt as you're looking at the GET capabilities request for any service to verify that the base URL is the one that you expect it to be for the specific request or operation that you're submitting. Again, for the described coverage, we're defining the service type and the service version. We then have a list of identifiers. And essentially, this is the list of coverage names that are included as a part of the service. So this is that short list of names for the coverages that you might seek additional information about. And again, the parameter name that we're looking for is identifiers to see the list of the coverages that are available from this service. For the GET coverage request, you can see here, again, the base URL, the service type, service version, and again, the list of coverages for which the GET coverage request or operation is applicable. Also, as a part of this information about the GET coverage request is information about available interpolation methods that users can optionally request, the formats that the data are available in, whether or not the data should be stored on the local system, or on the server, I should say. And then also the base coordinate reference system for the GET coverage requests in the absence of other specified spatial reference system or CRS parameters. And that is all of the operations metadata. Since we only have 3 operations, it's a relatively short section of the document. We then have the contents section where there is summary information provided about each coverage that provides that, again, that first glimpse at what each coverage consists of. So in the case of this particular coverage, where you can see there are multiple coverages that are a part of this particular WCS, if we look at this one right here, we have a title, which in this case is actually the same as the abstract, but they can be different. The identifier, which is the name that you would use in accessing this particular coverage. A list of keywords that are associated with this specific coverage. The bounding box, in this case defined in the image coordinate reference system, where this basically provides the pixel dimensions of the source coverage. Then an additional bounding box that defines the bounding box of the coverage in an additional coordinate reference system, in this case, the EPSG32661 coordinate reference system. And on top of that, a WGS84 bounding box that is specified in WGS84 lower left, upper right coordinates as well. So this provides you with immediate information about the coverage for that particular data set. You can also see that this particular data set is available as an image/TIFF file and a list of additional supported coordinate reference systems for requests for this coverage. So you can potentially request a coverage using a get coverage request for this coverage using any of these coordinate reference system codes. And this information is provided for each of the coverages in this service, where each coverage has a corresponding coverage summary. In some cases, you will want more detailed information about a particular coverage. To obtain that, you can submit a WCS describe coverage request. That is also a fairly simple request that includes a required service, version, and request, but also an coverage ID that specifies the coverage that you would like additional information about. So here, we can look at an example of a described coverage request that includes the required service, request, and version parameters, and then also this coverage parameter. Now, one thing to keep in mind is that here we are interacting with a WCS version 1.1.1 server, where the name of the key that you're specifying the identifier for the coverage is named coverage. In version 2.0.0 of the WCS standard, you instead actually provide coverage ID as the key name. So this is one of those instances in which the specific version of the standard that you're using does have an impact on the specific key name that you use in the request to the server. So here, since this is a version 1.1.1 WCS, we're supplying the coverage name that we would like additional information about using the coverage equals snow extent 01 key value pair in this instance. If we click on the link for this request, we get an XML file that has much of the information that we saw in the summary, but then also some additional information as well. So as we saw previously, we have the title, the abstract, the identifier, the set of keywords. Now we have an entire section dedicated to what's called the domain. And within that, we have a number of different bounding box sets within that domain. In some instances, there may actually be multiple elements within this domain. In this case, we only have this spatial domain, which has in addition to our bounding boxes, as we saw previously, additional information about the specific grid for the source data in terms of the coordinate reference system, the type of grid it is, its origin and offsets, the type of coordinate system it is, etc. So this is slightly more detailed information relating to the spatial domain than we received in the summary. We then also have this range section that includes some additional information about the field or fields that are a part of this particular data set. So in this case, we have a field that now has a title of snow extent with an identifier of pixels, where snow extent is the human readable reference for this field, but the identifier that you would use by name is pixels. We then see the available interpolation methods, and we see information about the one or more bands of data available as a part of this coverage. As the WCS standard is defined to enable support for multidimensional data sets, the concept of bands is an important one for being able to provide essentially linkages to those different dimensions or bands in those multidimensional data sets. So here we have a specific axis with an identifier of bands that basically tells us that we have one band in this particular data set. And then we see, as we saw in the summary, information about additional supported coordinate reference systems. So these are coordinate reference systems that can be specified in requests to this web coverage service for this coverage. And then, in this case, the one supported format for this coverage, which is the image/TIFF format. With that information in hand, we can then compose a get coverage request, where, again, with version 2.0, the model has been changed somewhat from previous versions for specifying the subset that you would like for a particular coverage, but the concept remains the same, where the key value pairs that you are required or optionally providing include, again, the service, the version, the request, where in the case of a get coverage request is request equals get coverage, the coverage ID for the coverage that you would like to retrieve the data for, and then an optional subset specification where you can define additional limitations on how the data should be processed before it is returned to you. That subset specification has a particular format, as is defined here from the version 2.0 standard, where you have here in the first block that subset spec that consists of essentially a dimension, which is a defined name, followed by a URI of some sort, and it can be any URI, and then a specified interval or point value inside parentheses. And you can see an example of such a request from the 2.0.0 specification itself, where you can see in this particular example, there's the service equals WCS, version equals 2.0, request equals get coverage, coverage ID, and then the identifier for the coverage, and then these three subset parameters. The first one consisting of the name, in this case it's a lon, which is a predefined name for longitude, a URI that defines essentially the units or definition of what value is going to be provided, and then inside parentheses, a point as defined by this pair of values. We have a second subset parameter here with a name of lat, with a URI that defines the coordinates that are going to be provided as being in the EPSG48526 coordinate reference system. And then again, the value corresponding to that pair of latitudes. And finally, we have a third subset that relates to T, a defined name for time, the URI that defines a particular model for the representation of time, and then within the parentheses, a time value. The combination of these three subset parameters actually defines a geographic and temporal subset that should be applied by the server in generating the data product that's going to be returned. So here we have a sample get coverage request from the NSIDC Atlas of the Cryosphere, which we've been looking at throughout this presentation, where again we're seeing a number of differences between the version 1.1.1 parameter names that we're seeing here and the definitions from the 2.0.0 version that has been used throughout in terms of defining the specification. But the concepts remain the same, where we have our base URL, we have our required parameters, including the get coverage request, our definition of the specific coverage that we would like to have be returned. In this case, this is a coordinate reference system request that is specifying which coordinate reference system we would like the data returned in, the definition of our bounding box, the format that we would like, and then the width and height of the returned grid in essentially pixels. But these are going to define the pixel dimensions of the returned data product, which is slightly different from the pixel dimensions that we were working with web map services in terms of the image that was returned. But there's some similarity in concept is in that the width and height specifications here tell the server how it should apply its interpolation algorithms to take the source data and present them to us in perhaps different pixel dimensions than the source data were originally in. So this request actually results in a file format that is not easily displayed natively in any of the applications that I'm using here. But if I were to click on this, I would actually receive a file that is a composite of some header information from the web coverage service and then a binary TIFF image that is the second part of that file, where applications that are implementing the web coverage service understand how to separate that WCS header information from the attached binary content. But in this case, if I click on the link, I'm going to get a file that is, again, not directly interpretable by the software that I have right here. So we've reached the end of our discussion about web feature and web coverage services. Hopefully you've been able to see the commonality between these services and the web map services that we discussed previously in terms of the key role that the get capabilities request plays in all three services for obtaining service metadata for the service as a whole, and then high-level information about all of the available feature types or coverages in the case of web feature and web coverage services, or as we discussed last week, the layers in web map services. Also, the metadata requests in web feature and web coverage services for obtaining more detailed information about specific feature types or coverages. And then the requests that can be submitted to WFS and WCS services to actually obtain the data that those services are presenting, where that again highlights the key distinction between web feature and web coverage services and the web map services that we discussed last week, where web feature and web coverage services are entirely focused on being able to deliver actual data values, where the web map services are oriented towards the delivery of map images, providing visualizations of the data without actually delivering the data values themselves. And with that, we're finished with our discussion of web feature and web coverage services. Thank you.